The context of wind turbine blades, they are getting larger as the technology progresses, and because of this, they are becoming more inaccessible, being offshore or in hard to reach places. Therefore, the technology needs to change to inspect them. The GU68 funding allowed us to create our own composite, which gave us the ability to create a controllable defect that you see within that can replicate faults within a wind turbine blade.
So my name is James Fox, and I'm currently in my 5th year of the MEng program here at the University of Glasgow. My part of this project involved the fully automatic data acquisition step, involving integrating the FMCW sensor with the Franca Emica Panda arm for full scanning of a composite wind turbine blade.
So the benefit of machine learning is automatic data signal processing. So the ability to integrate it within an operation, and especially within a certain software, and that results in an automatic classification. The biggest challenge was being able to take each separate stage and then being able to integrate it within each other. So the construction of the composite took a hefty period of time, then integrating that with our FMCW scans to then achieve a result which goes through our machine learning classification model and then for visual representation. Each of those sections worked individually, but again, bringing it together in one setting was the biggest challenge.
I am Lucia Therakopoulou and I'm studying electrical and electronic engineering. And my part of this project was creating the GUI for the visual representation of the machine learning code. And in this visual representation, we had a panel which presented the monolithic sample, which was colored based on the classification from the machine learning model. The FMCW radar results are quite difficult to understand, so the graphical user interface is a tool which facilitates their understanding. Also, the GUI allows for interactiveness between users.
My favourite part of this project was actually the weekly meetings where we could all compare the results that we'd been achieving throughout the week and see how it would impact the future work and collaboration between the team members.
The team began by conducting a proof of concept using available existing dataset, then manufactured their own experimental objectives and designed the data collection with robotic techniques. Then they implemented the data-driven modeling and finally showcased the entire process. So the whole process is very extensive and challenging, but they finished them very well as a team.
So the FMCW radar allows for surface and subsurface detection of different defects that are inhibited in wind turbine blades. Within the future, you can potentially deploy this on a drone that can go up, inspect a wind turbine blade, all whilst I'm from the comfort of home. And that's going to really allow for different analysation of wind turbine blades that at the minute you just don't get out there, which is going to save costs, reduce, increase safety as well for these engineers offshore.